Okay, so let's go through a couple of concrete examples using those facts from parallel and perpendicular lines. Now remember, parallel, what we got was that if L1 and L2 are parallel, L1 and L2 are parallel, the two vertical lines means they're parallel, then you know their slopes are the same. M1 equals M2. And vice versa. If you've got two lines that have the same slope and are distinct, then their lines are they are parallel lines. And then what we saw from perpendicular lines was that L1 perpendicular to L2, if they're perpendicular, that's true if and only if that their slopes multiply to -1. Or you can also think of their slopes being negative reciprocals of each other. Okay, so here's our problem to try to figure out is, okay, we've got a line that goes through 1, 3, and 3, 9. And we have another line going through, let's use green, -2, -2, and 1, -3. Let's determine if these two lines are parallel, perpendicular, and either. Okay, so based off of what we know about parallel and perpendicular lines, everything is in terms of slope, so we should probably determine the slope of each line. So to find the slope, you use the equation. So here's our slope equation. M equals y2 minus y1, change in y, over x2 minus x1. And this order doesn't really matter as long as it's the same. So you could also call the points, flip which one's x1, y1, which one's x2, y2. So it was really just the change in y over the change in x. That's our slope. So if we find the slope of the first line, so this is M1, we do 9 minus 3. So this is our y2, this is our y1, and this is our x2, and this is our x1. So we have 9 minus 3 on top, and we've got 3 minus 1 on bottom. So when we subtract these guys, we're going to get 6. 9 minus 3 is 6, and 3 minus 1 is 2, and so that equals 3. We'll do the same thing for the other line. So we're going to take minus 3, subtract -2 from that, 1, and subtract -2 from that as well, and that's going to give us minus 3 minus -2, that's minus 3 plus 2, and 1 minus -2, that's 1 plus 2. So this is 1 plus 2. This is minus 3 plus 2. And so that's going to give us 3. And this is going to give us minus 1. So that's going to give us minus 1 over 3. Oops. So this is -1/3. Okay. So if M1 is equal to M2 and they're not the same line, then they're parallel. And if M1 is equal to if M1 times M2 is -1, then they are perpendicular. And if neither is the case, then they're not perpendicular, they're not parallel, and that's actually the vast majority of lines aren't parallel or perpendicular. They're going to be some kind of funky combination, or some angle is going to go, between them. That's more lines are like that than parallel or perpendicular. So in this case, if we multiply the slopes together, hopefully you'll see M1, M2 is 3 times -1/3. And 3 times -1/3 is going to give us -1, because that's -3 over 3, and that's equal to -1. And so the slopes multiply to -1, so the lines are perpendicular. Easy peasy. Alright, so we're going to go ahead and take a look at these two lines on a graphing tool just to double check for our own sake that they are in fact perpendicular lines or look somewhat perpendicular. So I use this program called Desmos quite a bit for graphing and visualizing math. And I find Desmos, it's basically a graphing tool with a little bit more functionality to it. And unfortunately, Desmos isn't what you'll be using that much in AP Calculus. You'll be having to use your graphing calculators more. Your like a TI-83 kind of graphing calculator, something that looks like this, TI-83. You know, your typical graphing calculators. But I prefer Desmos because it's a little bit faster and more responsive and more intuitive to use with like draggable points and stuff like that than TI-83 is. And it's also on the web, so it's all online. You can download an app for it. And you can save your graphs that you like if you create an account, etc., etc. So let's go ahead and look at this one example we had earlier where we've got a line going through 1, 3. So let's go ahead and look back on it. We have a line going through 1, 3 and 3, 9. So x1, y1 is 1, 3. Let's find that point. It's right here. And x2, y2 is 3, 9. So that's up here. And then our other line is going through -2, -2, so that's right here, and 1, -3, and that's right here. And if we can see visually from this picture, we zoom out a little bit, yeah, these lines look pretty perpendicular to one another. Just to double check, I have slope calculators for each line. See, M1 slope is calculated using that slope equation, and that's equal to 3. And M2 is calculated using the slope equation for the other pair of points, and that's equal to minus 0.33333 repeating, which is -1/3. And it says right here, product of M1 and M2, if it equals -1, then they are perpendicular. M1 times M2, look, equals -1, boom, perpendicular. Alrighty. So that's one way to check our work.